This requires you not only to do the dimensional analysis, but also to make an inference. It says humans can see light with wavelengths between 400 nanometers and 700 nanometers. CO2 laser emits light with a wavelength of 10.6 micrometers. The question is, can humans see this light? Give it a try. Stop the video and come back later. Okay, here's how we can set this up. Really, the question is, if we're asking, can humans see this light? The question is this light between 400 nanometers and 700 nanometers? So let's find out how many nanometers it is. We don't know that, but we do know micrometers. We'll start out with that. 10.6 micrometers. Remember that little Greek letter mu means micro. Set up my dimensional analysis here by putting this long line, and then I'm going to put my target dimension. What I want to know is how many nanometers is that? Well, micro means a millionth. So that means there would be a million, or 10 to the 6th, micrometers in a meter. So I'm multiplying by 1. It doesn't change the size, but it does change the unit. Now I have how many meters this is, but that's not what I want. I want nanometers. If you recall from the units study, nano means 1 billionth, or 10 to the 9th. So in a meter, there would be 10 to the 9th nanometers. Again, I'm multiplying by 1. It doesn't change the size here of this wavelength, but meters now cancel, and my target unit's been achieved. I now am in nanometers. Now that I'm at the target unit, all I have to do is my arithmetic now. So I go to my calculator, and I'm going to take 10.6. I'm going to multiply it by 10 to the 9th. Remember, on your graphing calculator, second function, comma, puts the EE in there. It's 1 times 10 to the 9th, but you can skip the 1 part. The calculator's okay with that. I hit enter. Now I'm going to divide by 10 to the 6th. Second function, E6. Hit enter. Well, there's my answer. It turns out that this light is 10,600 nanometers. Well, that is obviously not between 400 and 700 nanometers. So we can't see that light. Here's another example for you to try. Speed of light is 2.998 times 10 to the 8th meters per second. How fast would that be in miles per hour? Stop the video, give it a try. All right, here's how we do it. Let's set it up over here. 2.998 times 10 to the 8th meters per second. Remember, per means divide by. Myself a big long dimensional analysis line. My target unit, miles per hour. I have to change two things. I got to get meters into miles, and I have to get seconds into hours. I'm going to work on the meters first. I know there are 100 centimeters in a meter, so I'll multiply by this to get myself in centimeters. Here's why I did that, because the one thing I can remember is 2.54 centimeters is the same thing as 1 inch, and this factor will get me into my English system. Well, now that I'm there, I know that there are 12 inches in a foot, so I'll use this factor to change to feet per second, but that's not what I want. I do know that there are 5,280 feet in a mile. So I'll multiply by this factor so that feet can cancel out. Now I got my target unit in the numerator. I want miles up there. I got miles up there. Let's work on the denominator. I have to change seconds into hours. Everybody knows that there are 60 seconds in a minute. So multiplying by this factor is like multiplying by 1, and we only change the unit, we don't change the speed. Everybody also knows that there are 60 minutes in an hour. So multiplying by this factor changes my denominator to the target unit of hours. Okay, I have my target units in the numerator and the denominator. The only thing left to do is the arithmetic. So back to the calculator. 2.998 times 10 to the 8th times 100 times 1 times 1 times 1 times 60 times 60 again. That's everything besides the ones that are in the numerator. So I'll sum that, or product it up. Divide by, open a parenthesis, 2.54 times 12 times 5,280. Oops, I think I missed a times there. Times 5,280. Close my parenthesis, hit enter. Okay, here's my answer. It's a pretty large number. I'm not going to bother to write it down, but whatever that is, some millions of miles per hour. You get the idea of how to do this.